This video is on the prefix summary, its implementation, and what it's about and its helpfulness. So let's say we had an array over here, and here our array consists of a 1, 3, 5, 7, and 9, and the index of the elements are labeled in green. Now let's say we had a function, and this function had two arguments, I and j. Now here's what we wanted to find in the function. We wanted to find the sum from array of I to array of j. So for example, if we call this function from 0 to 2, that would be the sum of array of 0 all the way to array of 2. That would be sum of 0, 1, 2. 1 plus 3 is 4, plus 5 is 9. So f of 0 to 2 would be 9. Now let's say, how would I implement this function? Well, a simple brute force implementation would be to loop through the indexes from I to j and increment a sum variable. So this is how we would do it. So given an array and two arguments, I and j, we would have a variable sum that starts with 0, and we would loop through an index variable starting with I, all the way less than or equal to j, incrementing every time, and every time we would add the value stored at that index in the array to the sum variable, and finally we would return the sum variable. So this would yield a time complexity of order of n, because for example, if our query was 0 to 4 in this case, we would have to loop through the whole array, being the worst case possibility. Now this is too slow, because let's say we had 1,000 function calls. Every time, let's say our arguments were 0 to 4, that means we would loop through the array 1,000 times just to find the sum, even if we're doing the same operation again. So this is too slow. Now that's why this video exists, and so we're going to talk about a data structure called prefix summary to speed things up, having the same intention. So given this array over here with 1, 3, 5, 7, 9, I'm going to construct something called a prefix summary. Now for this example, our prefix summary would look like this. Now what does it mean? So for example, given index 0, the value stored at this index is the sum of all the numbers before it in the array plus the number itself. In this example, since our index is 0, there are no numbers before it, and it's just the number itself, so it's 1. Over here, our index is 1, so the sum of all the numbers before it is 1, plus the number itself is 4, so we store 4 over here. So given example 3, the sum of all the numbers before it, 5 plus 3, 8, plus 1, 9, plus the number itself, so 7, that's 16. So essentially, the value stored here is just f of 0 to that index. And next, so to construct this array, we can do this in order of n. I'll explain why it is order of n afterwards. So the same function, we can rewrite it in a different way now, since we have constructed something called the prefix summary. So given integers I and j, we can construct something like this. So this function yields the same value as this one. So we're saying that given I and j, this equals prefix sum of j minus prefix sum of I minus 1. So what does this mean? Well, if you look at prefix sum of j, basically this is just the sum of from 0 to that value. So for j, let's say j was, let's say an example over here. So let's say we took f of 2 and 4. Let's say this value was 2 to 4. So prefix sum of j would be prefix sum to 4. So this 4 yields the sum of all these values. However, since our index I is 2, we want to exclude the values before index 2. So that's why we do this. Now prefix sum of I minus 1 has the value of all the sum of the numbers before the index I. So for example, 2 and 4, 2 minus 1 is 1, so prefix sum of index 1 is 4. So this 4 is the sum of this number and the numbers before it. So example for f of 2 to 4, that would be 25 minus 2 minus 1 is 1, so that's 4. This would be 21 since 2 to 4, so the 9 plus 16 plus 25. So that will be 5 plus 7 plus 9, so 16 plus 5, 21. So using this, our function would be much faster at just time complexity of order of 1. So let's implement this data structure. So we start with an array. For example, let's say an array was like so. And we want to construct a prefix summary. So we can write a function for that, and that function is going to be called build. That would return an array, given an array of which in this case will be this. So we're gonna so how do we construct this in order of n? So given an index, well, if you look at it, the index of just the position before it has the sum of all the numbers with that and all the numbers before that. So we can utilize for given 2, how do we find the number over here? We can utilize the number just before it, which is 4, which is the sum of all the numbers before 2, before 9, and we can just add that to 9 itself, and add that to 5 itself to get 9. So given 3, we can just utilize the value 9 plus 7 to get 16. Since this 9, so every time we don't have to loop through from 0 to that index to find the sum. We can just use the result that exists just before it. So we're going to have a variable that starts with 0 as the sum, and we're going to loop through the elements of the array. And every time we're going to add the element to the sum. Once we've added it to the sum, we're going to add that sum variable to our prefix summary. So we need to construct an array called PSA. Once we've done that, we can just return PSA. So PSA we can call from build of array. Once we've done that, we need to write a function for our queries. So given index I and given index j and given our PSA prefix summary. Now if I is equal to 0, we don't need to subtract 1 from it like this function over here, because that would be 0 minus 1 negative 1. There is no index negative 1. Since if I is 0, we already know that PSA of j holds the sum from 0 to j, so we don't need to do any of this stuff. So we can just return PSA of j. However, otherwise we have to return like so, if I is ever 1 or above. Now note, I will never be greater than j, because that's how our range works. So otherwise we return PSA of j minus PSA of I minus 1. So we can give an example, and that would be that's going to be from 3 to 6. 3 to 6 given a prefix summary. So that would be these 4 numbers over here. So 8 plus 6, that's 14, plus 1, 15, plus 4, 19. So that should be 19. Yep, we got 19. So this video was on the prefix summary, its implementation, and how it works.